Alright, Algebra 1A students. Welcome to part 1 of lesson 2.8. In this video we will be talking about how we use proportions to solve problems that use similar figures. Now, similar figures are two figures that have the same exact shape, but they are not the same size. Okay, they're not the same size, meaning one is bigger than the other, but they are exactly the same shape. One is just a blown up version or a shrunk down version of the other. Okay? When we see two figures that are similar, their side lengths always make a proportion. Okay, they always make a proportion. And just so we're clear, the little squiggly one line means is similar to. So one squiggly line means is similar to. That was not a very good one, but it looks like this here. Squiggle up and squiggle down and up. That means is similar to. So here we have two similar triangles. We know that they're similar, well, because we're told they are, but also because we can make proportions out of each of the side lengths. Okay, so like the 8 on this triangle would go with the 12 on the other triangle, right over here. The 8 goes with the 12. So if we make a fraction out of that, now those two side lengths, that fraction must be equal to any of the other two side lengths. So let's say the 12 on the left-hand triangle, which would go then with the 18 on the right-hand triangle. And if you were to do both of these fractions, you would find that they are, yes, indeed, exactly the same. There is another fraction here that's exactly the same as well. Both of those fractions are also equal to the 10 on the left triangle over the 15 on the right triangle. So all of these ratios are in the same proportion. They're all 2/3, if you want to look at it that way, if you reduce them down. So they're similar triangles because all of their side lengths are in proportion with each other, meaning they make a proportion. Okay, that's very, very, very helpful for us because that allows us to find missing side lengths of a triangle. Okay, so like in this example, they have triangle ABC and triangle DEF, and they tell us they are similar triangles. They want to know what is the length of DE, given that these two triangles are similar. So we're not sure what this length is. Not sure what that is, but we can set up a proportion to solve it. Okay, so if I look at the side that they want me to find, which is this x right here, DE, well, that side is in the same position as the 10 in the other triangle, right? The side length that is 10 in the other triangle. So if I do 10 over x, that would be a proportion or a ratio of two corresponding sides of these two different triangles, right? The other side length that I know in this bigger triangle here is a 16, and the corresponding side in the smaller triangle I know is 12 because it's here, 12, 16. Okay, so I've set up this proportion of side lengths of these triangles because I now have 10 over x equals 16 over 12. Now this is something I can solve with cross multiplication. Do 10 times 12, which is 120, and then do 16 times x, which is going to be 16x. Okay. And again, those have to be equal. I cross multiply after I set up this proportion. Now I will solve for x by dividing by 16. 120 divided by 16 would be just slightly less than 10. No, just kidding. Slightly less than 8. 7.5. Okay, so the answer is 7.5 when we solve that for x. And all I did was set up a proportion using these missing side lengths. Okay, I could obviously also do it for this side down here, for AC. I could find that one using the 12 and the 16, the 18 and the y. I could set up the same kind of proportion and solve that way. Okay, so to solve for a missing piece of a similar figure, set up a proportion as we've been doing in these last few videos, cross multiply and solve for the missing piece. Okay. This can also be helpful in real world situations, in word problem situations like this. You'll find that there are a lot of examples dealing with similar triangles that have to do with the sunlight, with the sun's rays, and making shadows. Okay. So the sun's rays strike the building and the girl at the same angle, forming two similar triangles shown. They want to know, how tall is this building? And here's what we know right now. Well, we know that the girl's shadow is 3 feet long, and the building shadow is 15 feet long. So we set up this proportion of the girl's shadow length over the building shadow length, 3 over 15. That proportion must be equal to the girl's height over the building's height, which I don't at this point know, obviously. 5 over x. Okay. So 3 over 15 must be equal to 5 over x. So I set up this proportion. 3 over 15 equals 5 over x. And now, again, I just want to solve for x by cross multiplication. Cross multiply this way and this way. I do 5 times 15, which equals 75. And it's equal to 3 times x. Now to get the x by itself, I divide both sides by 3. And I end up with x equals 25. Okay, so that building is 25 feet tall. Okay. I have one of these that I'd like you to try. Take a look at this problem. A man is 6 feet tall standing next to a flagpole. The shadow of the man is 3.5 feet. Shadow of the flagpole is 17.5 feet. And they want to know, what is the height of that flagpole? So pause the video, take a look at that problem, please, for a minute. And then come on back and I'll show you what we should get. Okay, the proportion that we should set up should say 3.5 over 6, which would be the man's shadow over his actual height, is 17.5 over x, which is the flagpole shadow over its height. So to solve, we do 6 times 17.5, divide by 3.5, and we get that x equals 30 feet. That is a 30-foot flagpole. Okay, x equals 30 feet. If you have questions about solving proportions that you write from similar figures, similar triangles, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.